Good morning, dear student. In this video class, we are trying to understand the concept of dimension. So here, what do you mean by dimension? Dimension of a physical quantity. We already know that there are several physical quantity, mass, volume, length, etc. So on. So what do you mean by the dimension of these physical quantity? First, knowing the meaning of dimension. Dimension means these are the powers raised to fundamental physical quantity to obtain the physical quantity is called as dimension. Dimension means these are the power raised to give a fundamental physical quantity to obtain the given physical quantity is called as dimension of the physical quantity. So here dimension after this dimension of physical quantity we are going to study about the dimension formula. So here in the dimension formula, we basically use three fundamental units, that is M, L, T. Here M stands for mass, L stands for length, and T times T for time. So here dimension formula means it is the expression represent the physical quantity in terms of a dimension. So dimension is these are the power giving rise to a fundamental unit to obtain a physical quantity. So for example, to understand this concept, let us take one example, velocity. You people are very familiar with the definition of velocity. What do you mean by velocity? Velocity nothing but distance traveled or distance or displacement divided by time taken. This is called as velocity. Then what is the SI unit of displacement or distance? Distance and displacement. These are the measured. It is a length. Distance means length. Length is measured by a meter. Therefore, the SI unit of distance is meter divided by the time can be here. The time can be measured by a second. That is measured by second. Sorry. Meter per second. This is the SI unit of velocity. So when we need to know about the SI unit, then only we can write the dimension of this physical quantity. Therefore, the dimension formula of this physical quantity, that is velocity. Dimensional formula for velocity means here M means meter. So meter comes under length. So L to the power of 1. Second, here second. Time second comes under second. Therefore, this goes to numerator. It gains negative power. So M is 0, L is 1, and T is minus 1. This is the dimensional formula for the physical quantity velocity. This is called as dimensional formula. We are going to discuss some physical quantity and their dimension formula like this. Here there are 8 physical quantity. Now here study. So here first one is area. The first physical quantity is area. Here area means what is the area of a rectangle? It is length into breadth. So the relation is length into breadth. Both are length. So both are measured by a here length also a distance and breadth also a distance. So both the quantity are measured by a meter. So meter into meter, meter square. So here meter square is the SI unit of the physical quantity area. Then dimension formula of this is n square, because here only meter square are there, only length. M and T are 0. Therefore, we simply write as dimension formula of this area is n square. No need to write the M and T here because there is no quantity of M and T. The next one is volume. What is the relation of volume? What is the volume of a cylinder? A three-dimensional picture, that is, for example, cube. What is the volume of a cube? That is, in cube all the sides are equal. Therefore, all the sides are equal to nothing but L into L into L cube. So L cube dimension formula is N cube. Here also there is no physical fundamental units, that is M and T. Here only N cube. And the next one is density. What do you mean by density? Density can be defined as mass by volume. Here mass by volume. The unit of mass is kg and volume is meter cube. Here the dimension formula is mass. Here kg goes comes under mass, and meter here meter cube is in the denominator, so goes to the numerator. That carries a negative power, that is L cube. M per M meter mass per M L to the power of minus 3 is the dimension formula for density. Next one is velocity. We already discussed this regarding this dimensional formula. This is L t to the power of minus 1. The next one is acceleration. Acceleration can be defined as the velocity by time taken. So velocity by time taken. Here velocity means displacement by time taken. So here 2 times the time here. That's it. So therefore the SI unit of acceleration is meter per second square. Here the meter per second square. Meter is length 1 and second square. Here t is minus 2 because x square. It is in denominator. The next one is a force. Force can be defined as mass into acceleration. According to the Newton's second law of motion, force can be defined as the product of mass into acceleration. The unit of force is Newton. The dimension formula like this. We already know that mass means kg. There is no mass m product here. M is 0. Acceleration is, we know that the dimension of acceleration is L t to the power of minus 2. Here the mass is kg. So here 1 m and L t square, mass into acceleration. The next one is work or energy, both as the same unit, that is joule. The SI unit of dimension formula of work and energy be like this: L to the power of minus 2 to t to the power of minus 2. Because work can be defined as the product of force into displacement. The force, we already know that the dimension formula of force, that is ml t square. One more addition is there, that is distance. Therefore ml to the power 2 t to the power of minus 2. The last one is power. The SI unit of power is watt. So power can be defined as work by time taken. We know that the dimension formula of work, that is m l to the power of 2 t to the power of 2 minus 2 divided by time. So one time will be added to here, that is goes to numerator, that is t to the power of minus 3. M L square t to the power of minus 3 is the dimensional formula for the physical quantity, that is power. These are the some physical quantity and the dimension. In the further classes, we learn few more physical quantity and the dimensional formula. So let's continue this. The topic, that is the dimension analysis. Dimension analysis. What do you mean by dimension analysis? Analysis of an equation by a method of dimension is called as dimensional analysis. Analysis of an equation by the method of dimension is called dimension analysis. Then, what are the application of dimension analysis? Why we need dimension analysis? So, next one is application of dimensional analysis. So, we need this because it is used to check the correctness of dimensional formula. And the next one is it is used to derive the relationship between various physical quantity. And it is also used to obtain can be to change the given physical quantity from one system to another system. These are the applications of dimensional analysis. The first one is to check the correctness of a dimensional formula. Dimensional formula means these are all the dimensional formula of physical quantity. It can be checked by a dimensional analysis. The next one is it gives the relationship between the various physical quantity. For example, it gives the relationship between these two. What is the relationship between area and volume? It can be obtained by the dimensional analysis. And one more is there, that is to change this system of one system to another system. The physical quantity, for example, system of units means MKS, CGS. We use this dimensional analysis. We can change from one system to another system. These are all the applications of dimensional analysis. Next, move on to the next topic. Next one is principle of homogeneity. Principle of homogeneity. Homogeneity or consistency. It is nothing but it is defined as the term in the all the term in both the sides of physical quantity is must equal, is called as homogeneity of a physical quantity. For example, Newton's second law of motion, that is F is equal to m into a. So we know that the dimensional formula of force. What is that? Force can be defined as mass into acceleration. Mass means kg. So m l t to the power of minus 2. This is the dimensional formula of force. M l t to the power of minus 2. Here also mass is there. Acceleration means distance, velocity by time taken. So here m by t square. So that is m l t to the power of minus 2. So observe here, in the both side of this physical quantity, f is equal to ma. Here three physical quantity, both are equal. This is the dimension of this equation. Dimensional equation of this physical quantity in the both side. Both side means LHS and RHS are equal. This is called as homogeneity, principle of homogeneity. It's nothing but the terms in the both sides of the equation must be equal. This is regarding about the homogeneity principle of a physical quantity. The next one is to check, for example, for this, to check the correctness of the equation of mv square equals to mgh, where here v represent the velocity, m represent the mass and h represent the height. So here we are going to check the correctness of this dimensional formula. So here we need to consider only physical quantity, because we need to check the correctness of a dimension only. So we need no need to consider a constant. So leave it. Consider here mass, again same as it is. Velocity square. Then velocity equals to displacement divided by time taken. That is distance means L divided by T. And here also m is mass. Here g equals to a. Here g means acceleration due to gravity is equal to acceleration. What do you mean by acceleration? Velocity divided by time taken. That is, velocity means L divided by T into T. So substitute these values to this equation, we get 1 by 2 limit m into L divided by T is equal to, here 2 times. In the place of V, I will put L divided by T whole square equals to m into G means L divided by T square into H means length, which means height. So therefore, m L square e to the power of minus 2 equals to m L square, here also L square e to the power of minus 2. So observe both the sides. The dimension will be like this. That is ml square e to the power of minus 2. Here also ml square e to the power of 2. This is regarding about the principle of homogeneity, to check the correctness of a dimension of a given physical quantity. This is the whole class regarding about the dimension of a physical quantity. I will stop here. It will continue in the next class. Thank you.